Acha, so what happens actually in thermodynamics initially to amader we have to know the laws, okay, and the laws that we are actually studying are the first law, second law, and the zeroth law of thermodynamics, which are like more or less very important. Apart from that, আমি যখন অ্যাপ্লিকেশন দেখি, সো অ্যাপ্লিকেশনের সময় আমাকে বেসিক্যালি ফার্স্ট লোর অ্যাপ্লিকেশনটা দেখতে হবে, অ্যান্ড ইন দেয়ার দ্য কার্নট সাইকেল প্লেজ actually a very very important role. Some of the key concepts that we are actually using in the first law of thermodynamics is the term like internal energy, heat, and work. So in general, if we just look into the first law of thermodynamics, তাহলে আমরা জানি যে আমি যদি বেসিক্যালি একটু হিট সাপ্লাই করি, আই হ্যাভ গিভেন সাম কাইন্ড অফ হিট টু আ সিস্টেম, a part of this heat will be actually used to increase the internal energy, and a part will be actually used to do the work, so which is the work done. So internal energy is a combination of kinetic energy and the potential energy of the particle. And also if we say what is the change in internal energy, then we just denote it by delta U. We have to remember that whenever we are basically using heat, and heat is actually changing in a system, then the internal energy will also more or less change. On the other hand, many a times you will see that there are processes like isothermal process and all, जहाँ पे the internal energy will more or less be zero. There will be no change in internal energy. Internal energy will be there, but change will be zero. Next is something which is heat. So heat we all know, okay, it's basically nothing but a medium, or a way how we actually are transferring energy, okay, from one point to another, and that can be actually measured by the temperature difference. So in general, whenever in thermodynamics, usually whenever this Q is greater than 0, heat is actually added to the system. So suppose you are basically having a box, and its temperature is 100 degree centigrade, and after some time it rises to 120 degree centigrade, mane we are adding heat to the system, so Q is greater than 0. But on the other hand, যদি এটা temperature drop হয়ে যায়, it goes to 80 degree centigrade, that means we are extracting heat from there. So in such cases we'll take Q is less than 0, in such cases we'll take Q is greater than 0. Now you might think that it is very obvious, but the thing is, while we do calculations and all, we have to use the sign minus or plus. তো আমি যদি মাইনাস ইউজ করি মানে হিট ইজ টেকেন away from the system, প্লাস ইউজ করলে মানে we have given heat to the system, so that's important. Okay, so the next thing is actually work. Now if you consider the work is the energy transfer basically that occurs. So in general we know, okay, that work done is equal to force into displacement. If we just write it down, force into displacement. Now this is very important. So in general in thermodynamics we are not going to use this relation. So force we can write it down in terms of pressure. Pressure is actually force per unit area, or we can say force is equal to pressure into area. So this is a term for force. So in place of this force I can write it down it as pressure into area. Now area is a two-dimensional thing. So for example, I have got this let's say a cylinder, and then this is a piston that I'm moving. Now if I'm moving this piston downwards, and let's say I have moved it by a very small distance, let's say dx, okay, very small distance dx, so let's say very small distance dx. But this piston on the top, if you look from the x and the y frame, you're basically going to have an area A. So if I multiply this area A, which is having a unit meter square, with the distance that it covers, which is having a unit of meter, it will be meter cubed. A meter cube money is more or less volume. So we can write this down as pressure into a change in volume delta V, right? If I write down dx, then I have to write it down as dV, and if I say that there is a small change in distance, I can write it down as delta V. So this is how we are actually going to get this relation, W is equal to P delta V. So whenever we are going to write down the first law of thermodynamics, we will always, mostly, not always, mostly we'll use this relation as well. dq is equal to du, internal energy, plus dw, but in place of dw many a times we are going to use the relation as pdv. So this is important as we are going to look into the derivation part. Work done also something which is similar. If we are basically having a system, and because of that system you are actually able to move a box, that means this system is actually doing work, okay, by on the box. So that means work is done by the system. So if I say work is done by the system, it is always more or less positive. And on the other hand, if you are doing work on the system, this is going to be negative. So a very simple example may be like this. You basically can consider a piston, okay, and maybe there is some kind of expansion. This is a system, and if the gas expands, the piston will move up. That means work is done by the system. On the other hand, if you push the piston back, that means this is the gas, that means work is done on the gas. Okay, let's consider the gas as the system. So if the gas expands, the piston moves, so work is done by the gas or by the system. So here the work done will more or less be positive. But on the other hand, if his work is done on the system, that means I can consider the piston and I'm pushing it back, so this work done would be negative. This is very important because sometimes numerical thake and you have to check whether the work is done on the gas or by the gas. So in general we can say expansion of gas, as I said, this one, and the compression of gas. Compression of gas hole work done is negative, expansion of gas hole work done is positive. Okay. So we have the four cases where we actually consider it in thermodynamics, and there are four. First is isothermal process, where the temperature is, change in temperature is not there. That means it is zero. So the temperature does not change in the system. Now, if the temperature does not change, the other parameters are also connected. If the temperature does not change, mane the internal energy will also not change. তাহলে if I say that dq is equal to du plus dw, okay, du will become 0. So we can simply write it down, dq is equal to dw, sorry. So we can integrate it and we can find out that q is equal to w. So we have to remember that temperature and internal energy are connected. If there is no change in temperature, no change in internal energy. Everything is connected. We are going to use these later. Next is adiabatic process. Adiabatic process মানে আমার q হচ্ছে 0. q হচ্ছে 0 means dq would be 0, right? dq is equal to 0. So everything we are going to look into from the perspective of first law of thermodynamics. So let me just write it down. dq is equal to du plus dw. So what happens is, if q is equal to 0, mane this will become 0. That means whatever is your internal energy, du is equal to minus of dw. If you just look into the maths, minus of dw. So the total work done we can find out will be nothing but the change in internal energy, and this is negative. That means work is done on the system. If there is no heat given from outside, that means you are doing work on the system. So that is also something which we should be careful. Okay. Next is isochoric process. I told you barik mane pressure ta constant, choric mane volume ta constant. So if I write down isochoric, that means delta V is equal to 0. There is no change in volume. Now what was our work done? Work done was pdv. Okay, if we write down small work done, then we can write it down as pdv. Now if there is no change in volume, that means this dv would be 0. No change. Dv means small change, means this would be 0. This would be 0 means work done would be 0. So when we consider an isochoric process, here the work done is 0. Okay, that means we can simply write it down as dq is equal to du. So obviously we can find out the total heat supplied, and what it means simply is ki whatever heat is we are giving as an input, the entire heat is used to do or change the internal energy. No work is done, only internal energy is changing because there is no change in volume. What you can think is like we can take a box, piston attached, and the piston is not moving. Okay, let's say it's fixed, so it is not moving. So you might keep on giving heat to the system, the gas will keep on expanding, but the piston is not moving. That means work done is 0, but the gas is expanding. Okay, so that means there is change in internal energy because you are giving heat. Okay? So that is one more idea. Next is finally the isobaric process. This does not hamper anything because the relation is dq is equal to du plus pdv. So p is the pressure which is already mentioned as p. Like whatever is the pressure, it will remain. So that is constant. So this will remain the same. That means our first law of thermodynamics does not change only in one case. That is when the pressure is constant, or it is basically an isobaric process. So pressure change na hole amar first law of same hi thakbe. Always remember, whatever process we are talking about, it is talking about change. It is not saying that the quantity is 0. That is only one case, adiabatic process. যেখানে আমি বলছি we are not supplying any heat. Apart from that, all the other processes, no change in temperature, no change in volume, no change in pressure. Okay, so change is important, not pressure. I cannot say that pressure is zero. I'm saying that the change is pressure is zero. Okay. So we'll have a lot of numericals from this. Okay, it's very easy to understand. It's not complicated. এটা আমরা করবো না exactly এখন. I'm just giving you some examples. Like for example, a gas absorbs 100 joule of heat. Okay, 100 joule and does 40 joule of work. Find the change in internal energy. So we can just simply use the relation dq is equal to du plus dw. Since the total heat and total work done is given, I can easily subtract them and find out whatever is the change in internal energy. So this is very simple because here they have not mentioned whether it is an isobaric process, adiabatic process and so on. Okay, simple question. If you look into something like this, let's say an adiabatic process, we know that adiabatic process আমার q টা হচ্ছে 0, so q is 0. So the question says the gas expands adiabatically and does 50 joule of work. Okay, so it will expand adiabatically মানে we are just giving a heat, we are not giving any kind of heat. Okay, it's just expanding without giving an external heat to it, so q is 0, but does 50 joule of work. Whenever w is there, w would be there, so w is 50, and if you use the formula, it is q minus 50. So q is 0, no heat is supplied, so it is minus 50 joule. So whenever such questions are given, that is why I've written this. If you know these questions are easy, but if you don't know these, then these questions will become difficult. So adiabatic expansion আমার এটা হচ্ছে is very important. Okay, so based on this you can get a lot of questions. I'm not going to do this. I will share the file with you. You can check. Adiabatic process এগুলো আমার হচ্ছে, এটা তো আই থিঙ্ক সিমিলার কোয়েশ্চেন. দিস ইজ অ্যান আইসোকরিক প্রসেস. আইসোকরিক প্রসেস মানে আমার ভলিউমটা কনস্ট্যান্ট, দের ইজ নো চেঞ্জ ইন ভলিউম. So we will calculate the change in internal energy. So if the volume is constant, that means there is no work done. W is equal to 0, so delta q is equal to q, delta u is equal to q. So whatever is the heat supplied, entire heat will be actually used to do the change in internal energy. So delta u is equal to 100 joule. Very simple. Next is isothermal expansion. Isothermal expansion আমরা জানি that delta u will become 0 and q would be equal to w, right? So there is nothing new in it, just whatever is the heat supplied, entire thing would be used to do work. Okay, so entire thing is used to do work, isothermal process. Okay, and similarly other questions. I'm not going into the details of these are very simple. Can do it. Okay, I can just look into this question. There is slight trick here. A system does 400 joule of work and its internal energy decreases by 200 joule. Okay, internal energy decreases মানে internal energy will become minus 200 joule. So only that minus sign you have to use. So you have to just look into it. Increase or decrease. Decrease you are using a minus, and increase you are going to use a plus. So then we can just look into it and then find out what is the heat supplied. So those things can be done. Okay, now this is important. Heat transfer in a cycle, we are not going to look into it from this point of view. We're just going to first do Carnot cycle, and maybe we can come back to this to understand it better. Okay. Now these things that we are going to look into now is about adiabatic, isocoric, isothermal and cyclic process. Cyclic process মানে when you start, okay, you come back to the same point. Now practically it may not be very easy that you can come back to the same point using the same path. Okay, so Carnot cycle which we talk about is actually an ideal cycle. Okay, and there we are actually going to talk about the work done by the engine. Let's say it's a heat engine, how much is the work done in one complete cycle and so on. So for that we should actually be able to know what is the work done in different thermodynamic process. Now if you're basically going to find out the work done, that means your force into displacement, that means pressure into area into displacement, that means it is simply pressure into change in volume. So you can take it PdV if you are considering a continuous process. তার মানে if you want to find out the total work done, you have to integrate. So here I am saying let the work done is 0 and I am going to work done W. So 0 to W, dW will give you W, and this side you are going from initial volume to the final volume PdV, because your variable is the volume here. Okay, So you can write down pressure in terms of volume if the pressure changes with volume, and it does happen. Pressure will change with volume. Mane, if you basically have a balloon and if you keep on inserting gas, that means the pressure is changing, but at the same time the balloon is expanding as well. So we can say that if we are increasing the pressure, the volume will change. Okay, so in certain special cases maybe we are keeping it fixed, so we are giving the pressure is increasing, but we are not allowing the volume to change. That is a different case, so that's thing which we are going to see. But in general we also know that pressure and volume are more or less connected, right? So this is important. So if you want to just find out the work done, you should know what is the relation for pressure, put it there and do the calculation. Okay, so for this, what happens is the relation for pressure will be different in different cases. Means four different cases that we have. The first is your isothermal process, and in isothermal process we know that our temperature is constant. তার মানে temperature যদি constant হয়, we know work done is nothing but pressure into volume. But if you're basically going to consider an ideal gas, please remember this, this is very important. Okay, whatever we are going to do our calculations on are based on ideal gas. Ideal gas simply means that it is going to follow this ideal gas equation. PV, money pressure into volume, is equal to NR into T. So your N into R, N money molar gas constant. Sorry, N is number of moles, R is the molar gas constant, T is the temperature, P is the pressure, and V is the volume. So you see that pressure and volume are connected. So that means from here I can say pressure is equal to nRT divided by V. So in the above relation I can replace this pressure with this relation. But we said that this is actually an isothermal process when a temperature is constant. So you can take this T out. R and N are anyway constant for that amount of gas. So we can write it down as nRT integration initial volume to final volume 1 by V dV. So this is my relation for work done, and we already know that like these obviously these basic maths we know we have to use that. Integration of 1 by x dx is log of x, right? So ln of x, I'm taking base e, okay, base e, that is base e x log of x. Now if I want to differentiate it from initial volume to final volume, okay, then I can simply write it down as ln of final volume Vf minus ln of initial volume, that is Vi. So by logarithmic rule, log of a minus log of b is log of a by b, so I can simply write it down as ln of Vf divided by Vi. So if we use this relation, we can actually find out what is the work done in case of an isothermal process. Okay, that's important. So our isothermal processes, this is the work done. Now why I'm doing this is because many a times you might get a question on what is the work done in an isothermal process, or you might get the question on find out the total work done in a Carnot cycle. So there you don't need to do the entire calculation based on marks. Actually if marks कम থাকে, then you should know this relation. If the marks are less, know the relation, use it. But if the marks are more, then of course you can derive it. So that's why I'm doing it separately, because you can get a separate question or you can also use it in Carnot cycle. So that was for isothermal process. Our next process is adiabatic process. Okay, now adiabatic process it's kind of different. It actually depends on the specific heat ratio, okay, or the specific heat of the gas. And in an adiabatic process the relation is actually PV to the power gamma is equal to constant. Now this is basically the pressure volume relationship, okay, pressure volume relationship for an adiabatic process. This is something which you have to remember. We may not be deriving this, but this work done is something which is needed. So for that I should know the relation between pressure and volume. So adiabatic mein jahan pe Q is 0, PV to the power gamma is constant. Now gamma is actually called the specific heat ratio, and gamma is equal to Cp divided by Cv. So here also we are going to use the for an ideal gas we know P is equal to nRT by V, but we are not going to look into it from this equation. We are going to use V to the power gamma, because that is what specific heat is all about. Okay, so if we look into this, constant divided by V to the power gamma, this is for ideal gas and this is for adiabatic gas, not isothermal in nature. So it is constant by V to the power gamma, so we are going to use this relation of C divided by V to the power gamma and do our integration, right? So that it simply means that we are going to just integrate it from Vi to Vf okay, and then we are going to write it down as C divided by V to the power gamma into dV. So we are going to use the same relation. C is constant, we can take it out, dV divided by V to the power gamma, so we can take it C here, and then nx to the power n minus 1, sorry, V to the power minus gamma plus 1, x to the power n plus 1 divided by n plus 1, that's the relation. Then this is again gamma plus 1. So this is my result here, and then I can take the limits as initial to final, and then put the final and the initial relation. Okay, and let's just check this. So you can take this relation, and then you can do your maths. Okay, so 1 divided by minus gamma plus 1, you can take it out, it will be only V to the power 1 minus gamma Vi to Vf. So put the upper limit and put the lower limit, and then you can actually get in terms of Vf and Vi. Okay, one more thing to note here is this relation is here. Whenever we are going to write down a relation something like this, as typical maths, PV to the power gamma is equal to constant. Okay, it means that whichever point, it may be the initial point or it may be the final point, this will always remain as constant. Okay, whichever P you take. So if I take P initial and V initial to the power gamma, it would be same as P final V final to the power gamma. There is going to be no change if you are multiplying P and V in this way, it's constant. So this is going to be the same, so they are all equal. That is what this relation usually means. So we are playing a trick here to just make it simpler. For Vf to the power 1 minus gamma, we are multiplying it with Pf Vf to the power gamma. There is not going to be any change whether we take Pi Vi to the power gamma or Pf Vf to the power gamma. And for Vi, we are going to take Pi Vi to the power gamma. Okay, so if we do that, we can say Pi Vi to the power gamma into minus Vi to the power 1 minus gamma. Okay, we can see that this is Vi to the power gamma and this is Vi to the power 1 minus gamma. So minus gamma plus gamma will actually get cancelled out. Okay, so this relation will actually become, let's take this as 1 divided by 1 minus gamma. For the first term, we can multiply it with Pf Vf to the power gamma into 1 minus gamma. So this will actually become Pf Vf to the power gamma thakbe ekhane, and this is minus gamma, so that plus minus will get cancelled. I'll get just Pf Vf, that's it. And then here I'm going to get something which is called Pi Va. Okay, all I'm doing it using this relation. Conveniently I'm using Pi once, and in the other place I'm going to use Pf. Okay, now if I do this, I can interchange Pi Vi, I can take it in front, so I'll have a minus sign out. So this minus sign will get multiplied with this, and I'll get gamma minus 1. So this is actually a very important relation for adiabatic process. Many a times people get stuck here, but what I believe is this is very important to remember. Okay, this is work done relations, please remember this. If you remember this, you can use it in a number of things. Okay, this is very very important. So this is the work done in an adiabatic process. Okay, so next is work done in isobaric process. We are doing it in detail because we are going to need it later, but directly we are going to use the result because we know how to derive it. Now isobaric process mane pressure is constant and work done is P dV. Pressure is constant, I can take out the pressure term outside, so I have taken the pressure term outside, and it is simply dV, so it is nothing but V, so it is Vf minus Vi. That means the change in volume, final volume minus initial volume. Now the interesting part is, see, it is just PdV, so it is the simplest one to remember. In fact, if you know what is an isobaric process, you can easily find out what is the work done in case of an isobaric process. ये तो बिना याद रखे भी हो जाएगा. You can just write it down here in the relation and then basically just do it, and that's it. Okay, there is one more interesting thing here. This is depending on the final volume and the initial volume, the work done. It does not depend from where to where, it does not depend which path you are following. Okay, it just depends on what is my final volume and what is my initial volume, that's it. So that means that such systems are called actually a conservative system. Okay, it does not depend on the path. So this is what is there with isobaric process. Okay, next finally we have got the isochoric process. This is even more simpler because idea is volume is constant. Volume is constant means then no work done, because W is equal to P dV. dV is constant, I mean no work done. So whatever may be on this side, it does not matter. The work done is anyway going to be zero because delta V is zero. So this is the simplest one, isoporic process, zero. Isobaric process, P delta V, second simplest one rather. And this is work done adiabatic. This one you have to remember, not that difficult to remember obviously. And this is isothermal. You will see that many a times they will give you numerical for isothermal process, and this relation will play a very important and vital role. So this is there for isobaric process. Okay, this is for a polytropic process. We can just learn it for general knowledge. Usually this is not used. Many a times, it may not be an adiabatic process. There will be a volume term which will depend on a factor n. N is just a number, okay, and this is PV to the power n is equal to constant. Okay, so just normal maths, we are actually going to get the same thing, only the in place of gamma we are going to write down n. Okay, it may not be specific it ratio all the time. So this is what is important, and after I share you this PDF, okay, I can just write it down and try to remember these results as well as the derivation. তার মানে এই দুটো ডেরিভেশন তো ইজ ভেরি ইজি, ওকে, ভেরি ইজি, ইউ ক্যান ইজিলি রিমেম্বার দিস. But these two derivations you have to remember the result as well as the steps. Okay, just don't mix up. Here we are just going to use the relation PV is equal to nRT. We are going to say that the temperature is constant, so P jaga we are going to replace it by nRT by V. And here we are going to use the relation PV to the power gamma is equal to constant. Bas. That is the only thing that you need to remember. Apart from that, everything is math, so I don't think it's going to be that difficult. Okay, so this is the summary of results of these four results. Okay, so this is very important.